everyone. Today we will study about transactions in DBMS. Now what is the transaction concept? What is a transaction? Transaction is a unit of program execution that accesses and possibly updates various data items in the database. Transaction must see a consistent database. That means a transaction should work upon a consistent database. During transaction, execution of the database may be temporarily inconsistent. When the transaction completes successfully or the transaction is committed, database must be in a consistent state. That means when before the transaction starts, the database should be in a consistent state. During the transaction, the database can go temporarily, it can become inconsistent, but after the entire transaction is complete, the transaction has to leave the database in a consistent state. After a transaction commits, the changes it has made to the database persist even if there are some system failures. Multiple transactions can execute in parallel in the database. Two main issues to deal with during the transaction, that failures of various kinds such as hardware failures and system crashes, they can happen when the transaction is taking place, and concurrent execution of multiple transactions. These are the two basic issues which occur during the transactions. Now, there are asset properties of the transaction. Asset means A stands for atomicity, C is for consistency, I is for isolation, and D is for durability. So, a transaction is a unit of program execution that accesses and possibly updates various data items in the database. To preserve the integrity of the data, the database must ensure first that atomicity, that is either all the operations are properly reflected in the database or none of them are reflected. Then consistency should be maintained, that is execution of a transaction in isolation preserves the consistency of the database. Then isolation should be there, that is although multiple transactions are taking place concurrently in the entire database, each transaction should be unaware of the other transaction that is taking place. Each and every transaction should feel that I am the only one who is accessing the database. But actually many transactions are taking place on the database. But every transaction should feel that I am doing it in isolation. Intermediate transaction results must be hidden from other concurrently executed transactions. That is, for every pair of transaction Ti and Tj, it appears that that either Tj has finished execution before Ti has started or Tj started the execution after Ti has finished. But actually this is not happening. Then durability should be maintained, that is after a transaction completes successfully, the changes it has made to the database persist even if there are system failures. Now, when a transaction takes place, there are some states of the transaction. The states are active state, partially committed state, failed state, aborted state, and the committed state. Now, active state. This is the initial state, that is the transaction stays in this state while it is executing. During an entire execution time, it is in the active state. Then it is partially committed, that is after the final statement has been executed, it is partially committed. Now, then comes the failed state, that after the discovery that normal execution can no longer proceed. That means the transaction has failed and normal procedure will not take place. Or it is aborted, that is after the transaction has been rolled back and the database has been restored to its state which was prior to the start of the transaction. Two options that it has been aborted are, first, the transaction is either restarted, can be done only if there is some internal logical error, or either the transaction is killed. And then the fifth state is committed, that is after the transaction has been successfully completed. Now see, first of all we have the active state. Okay, then from the active state it goes on to the partially committed state, and then it goes back to the final committed state. That means whatever the transaction, whatever operations it was performing on the database, that transactions have been committed successfully, that operations have been done successfully, and the database is now in a consistent state. That transaction has left database in a consistent state, that is committed. Then in between active and committed, we have a partially committed state. Then once it is the transaction is going on, it is in a partially committed state. From that, the transaction can also fail. Okay, and when the transaction fail, it will go on to the aborted state. That means it is not committed, so it is aborted. And when a transaction is aborted, all the changes that have been done in the database, they are rolled back. Whereas when a committed state is done, then the changes are there, changes happen in the database. Whereas when the transaction has failed and it has gone into the aborted state, then the changes which has been happened in the database, all the changes which happened in the partially committed state, that changes are rolled back when it goes into the aborted state or the failed state. Now, implementation of atomicity and durability. How do we implement? The recovery management and the shadow database scheme. What is recovery management? It is a component of a database system which implements the support of atomicity and durability. Then the other option, how we implement this atomicity and durability, is through making a shadow database scheme. What is that? We assume that only one transaction is active at a time, and there is a pointer called DB pointer which always points to the current consistent copy of the database. A copy of the database is made which is called as a shadow database, and a pointer is there called DB pointer which points to the current consistent copy of the database. All the updates that are made on a shadow copy of the database, and the DB pointer is made to point to the updated shadow copy only after the transaction reaches the partial committed state, and all the updated pages, they have been flushed back to the disk. In case, now this was if it is partial committed. Now after partial committed, it can go either to the commit state or it can go to the fail state, as we saw in the previous. See, we saw that after partial committed, it can either go in the committed state or it can go on the failed state. Now, what happens if the transaction goes in the failed state? Then the old consistent copy pointed to by the DB pointer can be used and the shadow copy can be deleted. Why the shadow copy is deleted? Because the transaction has been failed, and so all the changes which have been done in the database, they have to be rolled back. So rolled back, that means the shadow copy which we have made, that is deleted. And if it is okay, the transaction is successful, then the shadow copy, that is persistent.